using microcaps to spot on a TLC plate. These are the microcaps. I'm going to shake one out of its jar. So I got one microcap out of the jar here. Very thin capillary tube. Microcaps are usually used with this dropper bulb, but I will not use it like a pipette. I don't need any pressure, I just need capillary action. So here I'm going to dip the capillary tube into the solution. As I dip it in, the solution will creep up the capillary tube. Probably can't tell, but there's solution in the capillary tube now. And I just touch it to the TLC plate and the solution should come out. There. So that's a drop of my solution. The MIT video says draw a line. Real chemists don't draw lines, they just imagine lines. So I'll put another spot here. There. The solvent dries almost immediately, but the solute, what was actually in the solvent, is still on the plate. I will confirm that by looking in the UV. This is the UV viewing chamber for TLC plates. The lamp itself here is movable, but you shouldn't move it. The light that comes out, the ultraviolet light, is very dangerous. Should be off because the person who used it before turned it off. You're going to press up here and hold it until the light goes on. I'm looking through this portal here to see the light is on. What you can see through the viewing portal looks like this. So you have a glowing plate, and on that plate I see 3 dark spots. Those were the 3 spots I put on with my microcaps. You want these spots to be very intense and not very big. So if they're all spread out, then you did a bad job and you have to use less volume. The other thing I am looking for here is that the spots line up. It's supposed to be a race. TLC is a race, and the different molecules have to start at the same line, otherwise one gets a head start of the other. So this looks pretty good here. The spots are the right size and they're fairly well lined up. Before I leave the station, I'm going to turn off the UV lamp. Off. The UV lamp, or the UV light, is dangerous to human skin and eyes. This viewing portal here has a filter, so it blocks out the UV. If you were to reach in the box with the UV light still on, you're irradiating your hand, you're going to get skin cancer. Make sure you turn the light off. In normal light, my plate looks blank. To set up your developing chamber, this will be the developing chamber. I recommend a piece of filter paper on the bottom. The MIT video says put it on the side, you should put it on the bottom. So if you do it right, the filter paper fits the jar. So get the right size filter paper. And then I need some solvent. In this case, I'm guessing ethanol is a good solvent. So I will pipette just a couple mils of ethanol. So I'm soaking the paper at the bottom. Alright, so that's my 4th pipette, and this is my 5th pipette. So maybe about 6 milliliters total is what I've used, maybe 6 or 7 milliliters. And now, try again, put my plate in. That's perfect. The paper at the bottom will prevent the plate from sliding, which it's prone to do. If you have glass on glass, it'll tend to slide. Now I'm going to zoom in and we can probably see the solvent creeping up the plate. Okay, so there's solvent creeping up the plate. That's what it should look like. The TLC is now being developed. Molecules are moving up the plate at varying rates if I chose the right solvent. Alright, I'm going to show you what you do when your TLC plate is done. I should let this run farther, but I'm impatient. So I'm going to pull it out now. Use my forceps, pull it out. I've got to mark the solvent front before it evaporates. So with my pencil, make a little line there. There. That's how far the solvent crept up the plate. And really what you do is you measure how far did your molecules move relative to the solvent front. That's called an RF value. Solvent itself will evaporate, and once it has evaporated, I'll go look at this under the UV light and see how far did my spots move.